Hello to everyone. In this video, let us discuss halides of 6th A group elements. So see here, 6th A group elements form four type of halides. First, monohalides, dihalides, tetrahalides and hexahalides. These are the four type of halides formed by chalcogens. Let us see the hexahalides. Among hexahalides, which are more stable means hexafluorides are more stable. And SF6 is here, sulfur hexafluoride. SF6 is here thermally more stable and also that is high reactive. And in SF6, sulfur undergoes sp3d2 hybridization, and of course it is having octahedral geometry. So this is regarding which one? Hexahalides. Okay, then come to the tetrahalides. In tetrahalides, general formula we know that MX4. In that, sulfur hexafluoride is which one? SF for that formula. And sulfur hexachloride, these are examples of which one? Tetrafluorides. MX4 is the formula of tetrafluorides. SF4, SCl4 are some examples. In that, some important points we have to learn here. What are the important things here? Now if you come to any tetrahalides, those are having which type of structure means seesaw type of structure. SF4, SCl4 are having seesaw type of structure. And hybridization of central sulfur is sp3d hybridization, and they contain one lone pair of electrons. Tetrahalides are having one lone pair of electrons. So by donating lone pair of electrons, these can act as which one? Lewis bases. At the same time, by accepting lone pair of electrons, these can also act as which one? Lewis acids. By accepting lone pair of electrons, they can expand their octet configuration. By that, these tetrahalides of chalcogens acts as Lewis acids, and by donating lone pair of electrons, they also act as which one? Lewis bases. Now, some important things regarding SF4. SF4 is used as fluorinating agent. So like oxidizing, like reducing agent, now we can say what is that? Fluorinating agent. That means if we want to add fluorine to any others, we can use which one here? SF4. So SF4 is having that means which property? Means fluorinating property, that act as a fluorinating agent. Okay, then come to SCl4. So this is somewhat unstable liquid. SCl4 present in which state? Means here liquid state. So SCl4 is somewhat unstable. So these are regarding which one? Means some important things regarding tetrahalides of chalcogens. Now let us go for which one here? Dihalides. So one of the dihalides example is which one here? S2Cl2. Sorry, SCl2. SCl2 means sulfur dichloride. So how to prepare this one? See here. First, sulfur when treated with chlorine, what we can get here? Means SCl2. So by the direct combination of sulfur and chlorine, we can get which one? Sulfur dichloride. And what is the hybridization of central atom in dihalides of chalcogens? See here, sulfur undergoes sp3 hybridization. So sp3 hybridization means how to determine hybridization also I will give an example here. To determine number of hybrid orbitals, to determine number of hybrid orbitals, What is the formula? Group number of central atom. What is the group number of sulfur means 6 plus number of monovalent atoms. Monovalent atoms means hydrogen, fluorine, chlorine, bromine, iodine. So if these are present along with central atom, those number only we have to write here. So oxide, that what is here, that is group number of central atom plus number of monovalent atoms. Here two monovalent atoms are there. So 6 plus 2 minus charge. Here no charge present on SCl2. So minus 0 by 2. So now 8 by 2 means 4. So number of hybrid orbitals 4. So in which we can get number of hybrid orbitals 4 means sp3 hybridization. So like that, what is the formula to get number of hybrid orbitals? Group number plus number of monovalent atoms minus charge by 2. We get number of hybrid orbitals. If the answer here we got 2, the hybridization is sp. If number of hybrid orbitals we got 3, hybridization sp2. As we got number of hybrid orbitals 4, now the hybridization is sp3. And we can count number of lone pairs also. See here how to calculate that. Here number of lone, that means number of hybrid orbitals 4. But to this central sulfur, only 2 chlorine atoms are bonded. Compare them with relatives. So total here 4 rooms are available and 2 relatives are approached into that house. Means still how many rooms are vacant means 2 rooms. So think in that way. Total 4 hybrid orbitals are there. 2 are occupied by bond pairs. That means how many remaining lone pair of electrons means 2 lone pair of electrons. So like that, these dihalides are having sp3 hybridization, that central atom, and that has 2 lone pair of electrons. So due to the presence of 2 lone pair of electrons, this SCl2 is having, or dihalides of that chalcogens have which one here, bent structure. So this is sulfur and chlorine. Here one lone pair, here one lone pair. What is the geometry means bent or angular geometry. So this is the structure of which one, dihalides of chalcogens. So this is regarding dihalides. Now the last one is here. What is that? Monohalides. So generally monohalide means one halogen only should be there. But why we have written here 2 means not only halogen. M also we have taken 2. That indicates what here? Monohalides exist as dimers. So actually it is MX only, but that exists as a dimer. So that's why only the formula became here what? M2X2. Now one of that examples of monohalides is S2Cl2. So how to prepare this S2Cl2 means here 2 sulfurs when treated with chlorine, we can get here which one? S2Cl2. S2Cl2 we can get. And S2Cl2 again when treated with excess amount of chlorine, we can get 2SCl2. So these are the preparation methods of which one? Mono and dihalides. So first by adding sulfur and chlorine we get monohalide. That monohalide when treated with excess amount of halogen, we can get which one? Dihalide. So this is the preparation method of monohalides. Now let us see the hybridization of central sulfur here. So now same as per our formula, number of hybrid orbitals equals to, here central atom sulfur, its group number 6. No need to get confusion. S2 is there means how we have to take. No need to worry about that. Whether S2 or S3, whatever it may be, central atom sulfur group number 6. And number of monovalent atoms, how many? 2. So 6 plus 2 minus charge, no charge is here. So 6 plus 2 by 2, 8 by 2 means we get again 4. 4 hybrid orbitals means hybridization of this central sulfur is which one means sp3 hybridization. And S2Cl2 is having open book structure like which one? Hydrogen peroxide. S2Cl2 is having open book structure like which one? H2O2 hydrogen peroxide. And one important point is here regarding S2Cl2. 2 moles of ethylene when treated with S2Cl2, one compound we get here. What is that? CH2CH2Cl taken twice S, or we can write S here, taken twice S, of course plus S. What is this one means? Its IUPAC name is di 2-chloroethyl, di-2-chloroethyl sulfide, and this is also known as mustard gas, used as a war gas. So these are the important points regarding which one? Halides of which one here? 6th A group elements. Okay, now let us see that which one here? Oxygen. So what is oxygen, how to prepare oxygen, and what is the importance of oxygen? Let us see here. So first all of you listen here. Oxygen preparation. How to prepare oxygen? Let us see here. Oxygen is prepared by that means which one? By heating potassium chlorate. Potassium chlorate on heating will gives which one? Oxygen gas. And also by the thermal heating of which one? Nitrates. Potassium nitrate on heating produces which one? Oxygen. And that thermal decomposition of potassium permanganate KMnO4 on heating produces potassium manganate plus MnO2 plus oxygen. And similarly, silver oxide Ag2O on heating produces oxygen. And also by the electrolysis of water on electrolysis produces which gas? Means oxygen gas. Okay, then from the fractional distillation, by the fractional distillation of air also we can get which one? Means oxygen. So these are the different methods of preparation of which one here? Oxygen. And not only this, by heating potassium dichromate also we get which one? Oxygen. And these are the different methods to prepare which one? Oxygen. And what are the physical and chemical properties of oxygen? So we know that oxygen is colorless and odorless gas. It is having no color and no odor, and it is somewhat slightly soluble in which one? Water. Oxygen is slightly soluble in which one? Water. And then it is used as an oxidizing agent for many compounds. For oxidizing purpose we are using that. That means here sulfur dioxide